how heat exchangers function and their applications. Let's start off with the basics. A heat exchanger is exactly what it sounds like, a unit that transfers heat between two fluids. The heat always travels from hot to cold. This is often accomplished by running the two fluids side by side, as can be seen here. As the fluid flows through the heat exchanger, the heat from the hot fluid moves to the cold fluid. One important note is that a temperature difference must be present between the fluids in order for heat to transfer. One important note is that temperature difference must be present between the fluids in order for heat to be transferred. To maximize the temperature differential, a method called counterflow can be utilized. With parallel flow, the temperatures of the two fluids will approach the same temperature, which will only be somewhere in the middle of the two initial temperatures. To maximize the temperature differential, a method called counterflow can be utilized. In counterflow, the fluids are flowing in the opposite direction. This allows for the final temperature of the hot fluid to approach the initial temperature of the cold fluid. It is for this reason why counterflow is used in applications of heat exchangers. On ships, heat exchangers are used in boilers, condensers, HVAC systems, refrigeration, coolers, and heaters. Now we will take a look at the different types of heat exchangers. First, there's a plate-type heat exchanger. Plate-type heat exchangers can be thought of as a layered cake.
Cake! Everybody loves cakes. Cakes have layers.
I don't care!
The plates separate the different fluids just like the frosting separates the different types of cake. The flowing fluids get contained by the plates and gaskets. While both fluids run over the plates, heat is transferred. There are corrugations on the plates to promote turbulent flow. This turbulence increases the rate of heat exchange, and therefore is highly desired. Isn't that right, Drake? The pros of plate-type heat exchangers include their compact size, rapid response to temperature change, expandable for differing requirements, and are easy to clean. Some cons include the expense, potential for leaking plates, and the time needed to reassemble in the proper order. The second common heat exchanger type is the shell and tube. They have a more diverse use than the plate type, and often are used as a condenser within a steam system. The pros of this type are that they are highly effective, robust, and rather inexpensive. However, the cons are the risks of corrosion and fouling, and the large size which needs to be considered in engine room arrangement, removal, and maintenance. Baffles are often present to increase the turbulence. If you have trypophobia, the fear of clusters of small holes, bumps, or patterns, the tube plate of the shell and tube heat exchanger may not be for you. Compact heat exchangers are often used in smaller applications, as ambient air is often the cooling fluid. These could be of the plate fin or fin tube varieties. The pros of compact heat exchangers are the smaller footprints and energy efficiency. The cons are the high risk of fouling and lower temperature changes.
Oh yeah, it's all coming together.